this video, we'll go over binomial exponents. Let's start off with the first example, a plus b squared. So this is an example of a binomial exponent, where the base, so in this case a plus b, is a binomial which contains two terms. So in this we have an a and a b, and these are two terms which makes it a binomial. Now when students first take a look at a plus b squared, their first instinct is to write this as a squared plus b squared. However, that is incorrect, and that is the most common mistake made when evaluating binomial exponents. Rather, let's take a closer look at this binomial exponent. So in this case, a plus b is our base, and so we know that in an exponent, the base is being multiplied by itself over and over the number of times the exponent. So since the exponent is 2, a plus b will be multiplied by itself 2 times. So a plus b squared is equivalent to a plus b times a plus b. So let's evaluate this. So in order for us to evaluate this, we have to use distributive property. So let's start off by doing a times a. A times a is a squared. Then we can do a times b, which is ab, b times a, which is ba, but it can be written as ab, and then b times b, which gives us b squared. And then we can simplify a squared plus ab plus ab plus b squared as a squared plus 2ab plus b squared. So as we can see, a plus b squared is equal to a squared plus 2ab plus b squared. Now let's take a look at a minus b squared. So it's the exact same process as before. We're doing a minus b times a minus b. So we're multiplying the base, our binomial, by itself 2 times because our exponent is a 2. So in this case, we do a times a like before, a squared, a times negative b, which is negative ab, negative b times a, which is negative ba, and so we can flip this to make it ab, and then negative b times negative b, which is b squared. So as we can see, we can simplify this as a squared minus 2ab plus b squared, and so a minus b squared is equal to a squared minus 2ab plus b squared. Now let's take a look at an example with numbers. So 3x plus 6 squared. So an approach that you can have to this is what we've been doing with a plus b squared and a minus b squared, where we can multiply it by itself and do distributive property. So like before, this will give us 9x squared, 3x times 6 will give us 18x, 6 times 3x will also give us 18x, and 6 times 6 will give us 36. So then we can simplify this and write it as 9x squared plus 36x plus 36. So this is an approach that you can use to solving binomial exponents. Another approach, which is a little more simple, is if we used the previous expression we came up with. So when we had a minus b squared, we were left with a squared minus 2ab plus b squared. Now instead of a and b, what if we substituted our two terms? So in this case, x minus 2 squared, our two terms are x and 2. So wherever there is a, we can substitute in x, and wherever there is b, we can substitute in 2. And so we'll get something like this: x squared minus 2 times x times 2 plus 2 squared. And when we evaluate this, we get x squared minus 4x plus 4. And this is because x squared is x squared, negative 2 times x times 2 is negative 4x, and 2 squared is 4. And so x minus 2 squared is x squared minus 4x plus 4. This concludes binomial exponents. If you have any questions, you can leave them in the comments below, and they will be answered.